Now let's talk about counting sort. So till now all the sorting algorithms that we saw were comparison based algorithm, right? Bubble sort, merge sort, selection sort, insertion sort, quick sort. All of these were comparison based algorithm, which means we compared two elements and based on them we sorted the array. Also, the best time complexity that we could achieve in worst case scenario was O of n log n. So generally when we talk of time complexity in general, we generally talk about worst case time complexity, and the best we could achieve from all of these algorithms was O of n log n, that was in merge sort. Okay, now we are going to talk about counting sort. So this is a linear algorithm. The time complexity will be linear. We'll see how. This is a stable algorithm, which means that if this 2 is coming after this 2 in the original array, then in the resultant array also this 2 will come after this particular 2. Okay, and another thing to note about counting sort is that it's a non-comparison based algo. Okay, now let's just go ahead and see the crux of counting sort. So at the end of the day, in counting sort, the agenda is to find the right position for a particular element. So in this case, let's say we have two temporary arrays and we'll see the use, and let's say this is the resultant array. So my agenda is to find out that where do I put fifth in this particular array? What is the right position for fifth? Okay, and for that what I need to know is that how many elements are less than fifth or equal to 5. So now let's say there is a single occurrence of 5 and there are 3 elements that is less than 5. Okay, which are those elements? I don't care. I just know that there are 3 elements less than 5. So in that case what I'll do is that I'll simply put 5 at the 4th position, right? Similar thing is happening in case of counting sort. So let's just see how we try and find out the position at which a particular element should go. Okay, so in order to find out that how many elements are smaller or equal, first of all what we will do is that we will store occurrence of each and every element. So now in order to store the occurrence for that matter, I need to know that what is the range of numbers that is there in this particular array. So let me put the index. So when I say range, it means that here as you can see minimum number is 0, maximum is 6. So I need to know basically this particular number. So what will happen is that I need to know what is my k. Okay, I need to know what is my k. Why? Because what we will do is that we will go to all the elements from 0 to k and I'll find occurrence of each and every element in this particular array, and we will find out how many times that number is storing. And let's say first I store in this particular array. So let's start doing that. So we will put the index here as well. So size of the array is going to be k plus 1. Okay, now we find out for 0 how many times 0 is occurring. It is occurring 1 times. How many times 1 is occurring? 1, 2. How many times 2 is occurring? 1, 2. How many times 3 is occurring? 0. How many times 4 is occurring? Okay, this is 1, 4. So this is 1. How many times 5 is occurring? Here is 5, 1. How many times 6 is occurring? 1 time. Okay. Now I know the occurrence. Now let's say if what I do is that to find the position at any point, I need to know how many elements are smaller than that number and how many elements are equal to that number. We will see the use case of this. So basically I need to know the count of elements smaller than this and equal to this. For that what I'll do is that I will keep on storing the cumulative sum in this. Okay, so I'll start from here. So first I will just copy this one here. So this is as it is. So this is actually the same array. We are using the same array here. So let's say we call it, let's say count array. This is also a count array. We are just modifying it, starting from here. So this remains same as it is. Now what I'll do is that for this place, I'll make it this plus this. So all the elements less than equal to 1 is going to be 2 plus 1, 3. Okay, all the elements less than equal to 2 is going to be 3 plus 2. It is 5. All the elements less than equal to 3 is going to be 5 plus 0. So it's 5. All the elements less than equal to 4, it's going to be 5 plus 1, 6. All the elements less than equal to 5, it's going to be 6 plus 1, 7. Okay, all the elements less than equal to 6 is going to be 7 plus 1, 8. Okay, now I have this information. Now let's start filling this particular array. So now let's say I start from here. I have to find out that where do I put my 2? What is the right place for 2? So now for right place of 2, and since what is happening is that I'm starting from right, what I'll do is that I'll find out that what is the value of count of 2, which is this particular index. This is 5, which means that there are 5 elements which is less than equal to 2. Okay, so what I'll do is that if there are 5 elements less than equal to 2, which means that this particular 2 will go at the 5th position. 0, 1, 2, 3, 4, 5, 6, 7. So let's say I don't care, that there are 4 elements less than 2 and 1 element equal to 2, or for that matter there are 2 elements less than 2 and 3 elements equal to 2. I don't care. I just care that there are 5 elements less than equal to 2, which means that if what will happen is that I will place this particular 2 at the 5th place. 5th place, which means 4th index. So I'll simply put 2 here. What is my 4th index? This is my 4th index. I'll put 2 here. Okay. Now what happens is that as soon as I put 2 here, I know that 1, 2 is already placed. So next time if I encounter any 2, it should be not placed here. Okay. So the number of 2's remaining will reduce. Okay. So what I'll do is that I'll reduce this by 1. So I'll make this 4. Okay. So that next time when I find my 2, the next 2 should go here, right, at the 4th place. So for that I just reduce it by 1. So anytime if I place a number, I'll just reduce its count. Okay. Now let's say what I do is that I go to 5. Okay. I'll go to index 5. So what is index 5? This is index 5. This is 7, which means that there are 7 elements less than equal to 5. Okay. So this particular 5 will go at the 7th position, which is 6th index. So I'll put 5 here. Now we have 6. So what is the value of 6 here? It is 8. So I'll put it at index 7. So what I'll do is that after I have put it for 5, I'll reduce it to 6. I'll reduce it to 7. Okay. I keep on reducing every time I put an element. I'll reduce it at that particular index in this count array. Okay. Now I've added this. Now I go to 0. Okay. How many times 0 is occurring? 1 time. I'll put 0 here. Okay. And I'll make it 0. Now I go to 2 again. So now I come back to this particular place. Now I have already placed this particular 2. Now there are 4 elements which are less than equal to 2, which means that this particular 2 will go at the 4th place, which is 3rd index. So I put 2 here and I reduce it to 3. Okay. Now I go to 1. Okay. I go to index 1. So this is the rightmost one. So I'll just put this at the index 2, 3rd place. I put 1 here. I reduce it by 2. Now I go to 4. Okay. So I go to index 4. Now this is B. This is my index 4. This will go at the 5th index, right? I'll reduce it to 5. So I'll put here 4. Okay. Now what I'll do here, I'll go here 1. So for 1, what is the value? 2, which means it will go to the 2nd place, that is index 1. So this is how I populate this particular array, and as you can see, this is a sorted array. So we have taken care of the stable situation by traversing the array from the right. So what is happening is that, let's say if we have, this is the situation. So this is the situation. Okay. So now let's say this is the 2 that is, since we are coming from the right, we ensure that we place this particular 2 first. So this particular 2 is supposed to go to the 5th position, right? There are 5 number of elements less than equal to 2. Okay. So I'll put this particular place, this particular 2 at the 5th place. Then when I get my next 2, I'll place it at 4th place. So this way we are ensuring the stability of the algorithm. So this is how counting sort works. It's pretty simple. We start with counting all the elements, then we find the cumulative sum as we go ahead, and then just by seeing this, the concept is simple, that you find out that for 5 what is the value of this count 5, and you just place the element at count of 5 minus 1 index. Okay, because if position is 4, index will be 3. Now let's just go ahead and see the code. Hope you have understand. Make sure for this particular array you do it once on your own and try and write code on your own before you just go ahead and see the code, because now I have explained everything and it's really easy to write the code. Okay, let's just go ahead and see the code. So now this is the code for counting sort. I have taken other array here. So here let's say the indexes are 0, 1, 2, 3, 4. Let's dry run it, and as we dry run it, we will also see the code. Okay, so now first thing that we will do is that we are having the parameter array. This is the original array, which is this, and we have n number of elements, and we have k. Here is going to be 6. Okay, now we will have another array c, and the size will be k plus 1. So we will have another array c. So it's going to be 0, 1, 2, 3, 4, 5, 6. Okay, so it starts from 0 and goes up till 6, and the size is k plus 1. We'll have another array b. So this b is going to be the resultant array that we will have. Let's make a b array over here. I'm not very great at drawing straight lines. Okay, I had only 0, 1, 2, 3, 4. This is going to be my b. This will be the resultant array. Okay, now let's just go ahead and start from here. So first what I'll do is that I'll populate all my c of I equal to 0. So all of these will be populated to 0. Okay, initially I'll just assume all the occurrences are 0. Now I have to find the occurrence. So what I'll do is that in this particular array, I'll start traversing from I equal to 0. So I'll start traversing from here, and every time what I do here is that as soon as I find any particular number, I'll just go to that particular index. So let's say when I find 2, I'll go to index 2 and I'll just increment the count of index 2. So this is what I'm doing, c of array of I. So let's say I here is 0, array of I is 2. So c of array of I here is c of 2. I'll make this as c of array of I plus 1, c of 2 plus 1. So now c of 2 is 0, I'll make it 1. Okay, now I go here again we get 2. Okay, again I do the same thing, c of 2 is equal to c of 2 plus 1, so I make it 2. Okay, now I go here, I have value as 1. Now the value of 1 will be 0 right now, it is 0 right now, so I increment it by 1, so it becomes 1. Okay, now I have 3 here, I go to index 3. What is the value of index 3 right now? 0, I increment it to 1. So as you can see, I start from 0. In this case, I start from 0 and I go till n minus 1. So I go till 6. For 6, the value is 0. I increment it by 1, I get 1. So this is how this counting array looks like. Now, this particular part is to find the cumulative sum for each and every index. So it starts from 1. So we will do that. Okay, so we have 0, 1, 2, 3, 4, 5, 6. Okay, so now for I equal to 0, we will keep it as it is, so it will remain 0. For I equal to 1, it will be c of I plus c of I minus 1. So it's going to be this plus the value that is here. Here the value is 0 only, so it's going to be 0 plus 1. So I put 1 here. So for 2, it's going to be 2 plus c of I plus c of I minus 1. So it's going to be 2 plus 1. It's going to be 3. Okay, now in this case, it's going to be c of I plus c of I minus 1. So right now, c of I minus 1 is 3. This is c of I and c of I minus 1 is 3. So it's going to be 3 plus 1, 4. Okay, so now let me see if I'm doing it right. So it is 1, 3, 4. Okay, yeah. So now I go here, it is 0. 0 plus 4 is 4. I go here, 0 plus 4 is 4. I go here, it's 4 plus 1, 5. So this particular part of the array did this particular task. This particular part of the code did this particular task. Now I go here. Here we are doing the task of placing the elements in the array at the sorted order. Now what I do is that I start from the back. Okay, I start from n minus 1. So this is something that is easy to understand, but don't worry if it is like you must be thinking that this is something complex, but it's easy. So what I do is that I have to find out the right place for 6. Forget about this thing. Let's try and write on our own. So I have to find the right place for 6. So let's say I have to find the right place for array of I. Right? I have to find the right place for array of I. So how we will find that? So let's say this is the array C. So we always found the place for a particular number by going to the C and finding the index, finding the value at that particular index. So it's going to be C of array of I minus 1. Okay, so C of array of I minus 1 will give me the right place And where do we have to put it? We have to put it in this array B. So it will be like B of C of r minus 1 is equal to r of I. So in this case, let's say r of I is 6. Okay, so we will be like, what is C of 6? C of 6 is, I can see 5. Okay, so we will be like B of 5 minus 1, which is 4. B of 4 is equal to r of I. What is my r of I? 6. So B of 4 is equal to 6. So I will place my 6 over here. Now let's say I go here. Okay, so now we have to do for 3. So similarly, we have to find what is B of 3. What is B of 3? Sorry, what is C of 3? It's going to be 4. Okay, so it's going to be 4. So we have to be like B of, this value gives me 4 minus 1 is equal to 3. So what is B of 3? It is 3. So I'll put 3 here. Similarly, for 1, what I'll do is that, and one more thing to note here is that after I just put the number, I have to also keep on reducing it. So once, what we will do is that once we take the number, we reduce it. So here in this case, what number I took? I took 6. So after I took 6, I'll reduce it by 1. I'll make it 4. Okay, so after I took 3, which is here, I reduce it to 3. Okay, and after I will take 1. So let's say what is happening here is that 1 is at 3rd position. So I'll put it at index 3, index 2. I'll put 1 here. My bad. Okay, 1 is here. Sorry, my bad. So now 1 is here. So what I'll do is that I'll put 1 at which particular place? It's 1st position, which is index 0. So I'll put 1 here and I'll reduce it to minus 1. Reduce it by minus 1, it will go to 0. Now I come to 2. I come to this place. What is the right place? 3rd position, which is index 2. I put here. Similarly, I make it 2 here. Now again, I come for this 2. I find 2nd position, which is index 1. So I put 2 here. So this is how I get my sorted array. Okay, so make sure you understand this well. Okay, write this code on your own. This is something you can really write. At the end, you have the option that whatsoever is the array, this is the resultant array, you can copy back to the original array. Okay, now what is going to be the time complexity? So let's see that. So this particular array will run k times. This particular array will run n times, this particular loop. Okay, this particular loop will again run k times. This particular will run actually k minus 1 time, I think. Yeah, it will run k minus 1 time. No, this runs actually k plus 1 time, and this will run k times. Okay, doesn't matter that much anyways, still. So this particular loop will again run n number of times. Okay, and this is something we can again say that it will run n number of times. Okay, now let's see the time complexity. So this particular loop will run approximately, will have the time complexity of O of k. This will have, let's say, O of n. Okay, this will again have O of k. Okay, this will again, let's say, have O of n. Okay, so basically this will run, I'll say, k plus 1 time. This will run n number of times. This will run k times. This will run approximately, this will also run n times. Okay, so this is how it's going to be. So the total time complexity you can say is going to be O of k plus O of n plus O of k plus O of n. So you can write it down that time complexity is going to be O of n plus O of k. Okay, so now what happens in this particular case is that if k is something that is comparable to n, okay, if k is something that is comparable to n, I can say that time complexity is O of n. But let's say if k is a really high number compared to n, in that case we can say that time complexity is O of k. Okay, so though this is a linear time complexity, but if the value of k goes too high, then in that case counting sort will not be that optimized. Okay, so let's say if the value of n is really not much. So let's say if it is just 0, 1, 2, 3, 4. Let's say the value of n here is, let's say, 5. Okay, so let's say even in worst case, let's say time complexity will be O of n square. Okay, that won't be that much. Whereas let's say if k here is 2 to the power, or let's say it is going to be 2 to the power 10. Okay, or let's say it is something like 10 to the power 6. So this number is very much higher from this particular number, because n is comparatively smaller and n is very high. So this works in the most optimized way when n and k are approximately at similar levels, or let's say the value of k is smaller than n. Okay, now what is the time complexity? I did not include this particular thing because you can choose to copy the array or you can let it be that way as well. Okay, anyways, if you copy the array as well, the time complexity still remains the same. Now what is the space complexity? So we are using two temporary arrays. So this particular array is again O of k and this particular array is again O of n. So this is the space complexity for counting sort, and this is going to be in best case scenario as well as worst case scenario. This is going to remain the same. Okay, now what we will do is that we will just go ahead and talk a bit about radix sort and bucket sort. So first let's talk about radix sort. So the agenda of radix sort, or the idea of radix sort, is pretty simple. So let's say you are given numbers here. So let's say you are having number with d digits. Okay, or let me put it again, you are having number with d digits. Okay, in this case we are having 3 digits number. I have written 2 as 002. We will see why we have written that way. So what will happen is that there are, let's say, n numbers. So what we do is that in this case we will first sort the least significant numbers. So let's say we will sort all the numbers at this particular place. So what we will do is that we will actually sort the complete all the numbers based on their least significant digit place. So let's say what happens is that, let's say I start sorting based on this particular number. Okay, based on this particular digit I will sort the complete set of numbers. So how will my set looks like? So what will happen is that this is the smallest, so 400 goes at the first place. Then this is the second smallest, so 031 goes at the second place. Just see this particular last digit numbers. Okay, just see that. Okay, and the next one is 222. So I'll put 222 here, 002, 002 here, 315. 5 is the 5 is the least one and 5 is having the largest value, so this will come at the end. So based on the last values, what I did, based on the least significant value, I sorted this particular array. Now I'll go to this particular place. I'll go to the second least significant number. Okay, so now based on that I start sorting. So what will happen? So let's say which is having the lowest value in this particular place. So I see 400 is having, so I put 400 here. Second one is 002, I put 002 here. Then we have 1, which is the smallest after 0, so we put 315 here. Then we have 222, I put 222 here. Then we have 3 here, so I put 031 here. Okay, now I go to this particular place and based on this first place values I will sort the array. Okay, so now here again, which is the smallest, this here we have 002 as the smallest. So what is happening here is that we are using counting sort to sort the number. So if you are using the counting sort, it is going to be stable. So if 002 comes here first, so in this case also this 0 will come first. So this 002 comes here, and again here we have 031. So this 031 comes here. Then we have 222 here, 222 come here. The next number is going to be 315. Since 3 is greater than 2, it comes here, 400 comes here. So at the end of the day, we get the sorted array. So we keep sorting the numbers based on their place. So let's say this is the least significant digit, this is the most significant digit. So digit by digit, I keep sorting the array. And every time I sort, I use counting sort. Okay. So now let's say if there are n numbers, okay, and if let's say the maximum number of digit a number is having, let's say, is d. Okay. So the total time complexity is going to be O of n into d. Okay, so let's say if n is very large compared to d, it's going to be O of n. And as I said, we are using counting sort to sort the array at each and every place. This is again a stable algorithm. Okay, now let's go ahead. Now let's talk about bucket sort. So bucket sort we generally use when we have to sort a range of numbers. So in this case, we have taken range of number from 0 to 1. So what is the idea? The idea is to create a bucket and to put values in the bucket, and we ensure that the individual bucket is sorted, and then we combine all the values. So let's say, let's have the bucket 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So for this range of numbers, I kept 9 bucket, actually 10 buckets starting from 0 to 9. What I will do is that I'll go and see after this decimal point. So after this decimal point, if there is any number that starts from 0, I'll put in this particular bucket. If let's say this is a number that starts with 2, after the decimal, let's say the number is 2, I'll put in this particular bucket. If it is 1, I'll put in this particular bucket. If it is 4, I'll put in this particular bucket. If it is again 1, I'll put in this particular bucket. 0, this particular bucket. 0, this particular bucket. 1, this particular bucket. And now, as I said, is that I'll keep on putting the numbers, and as I put numbers in the bucket, I ensure that they are in a sorted manner, and then I'll just combine all the elements of the bucket. Okay, so now let's start putting this in the bucket. So first one is 0.25. So let's say I put 0.25, it will go here 2, so I put 0.25 here. Okay, now it's 0.12, so I put 0.12 here. Now it is 0.43, so I put 0.43 here. Then we have 0.15, so it's going to be here again. So now when we put 0.15, what we do is that we use insertion sort to find the right place for 0.15. So we will put, let's say if there is an element that is already existing in a particular bucket and a new element is coming, it will be inserted in an insertion sort manner. So let's say I put 0.15 here. Then we have 0.04, so I put 0.04 here. Then we have 0.01, so 0.01 will come even before 0.04, so let's make it 0.01, and then we'll have 0.04. Then we have 0.112, so it will go in this particular bucket. So it is 0.112. What is the right place? It will be even before than this, so we will have 0.112, then we will have 0.12. So now I'll combine all the numbers starting from top. So we'll have 0.01, 0.04, 0.112, 0.12, 0.15, 0.25, 0.43. So this is the idea of bucket sort. So you can think that how will you make the bucket? Okay, that is up to you, that how do you make the bucket and what is the criteria you put in over there. Okay, now let's see the time complexity. So let's say the best case time complexity occurs when the size of the bucket is such that all the elements, or for that matter you have made the bucket such that all the n element go to each bucket. Okay, there is only one element in one bucket. So what will happen is that there are n number of elements that will be there, and it will take just each element will take just one O of 1 time to get inserted, right? So total time complexity is going to be O of n. Okay, so there are n elements and each element is taking n time to get inserted. Okay, now let's say we have another scenario in which what is happening is that all the elements are in the same bucket. All the elements are in the same bucket. So as we saw that in this case, we are using insertion sort to put an element. So in this case, in worst case scenario, we will have the value of time complexity as O of n square, because the worst case scenario of it is just like sorting an array using insertion sort. So it will go around to be O of n square. Okay. And what will be the space complexity? Space complexity is going to be the size of the bucket. So let's say in this particular case, what will be the size of the bucket? Again, that depends upon the size of the bucket. So let's say if the size of the bucket is k, okay, let's say it's going to be O of k plus it will be O of n. Okay, this is size of the bucket plus we are placing these n elements. Okay, so now this is how this particular bucket sort will go. Okay. So we have gone through all the sorting algorithms. Make sure you understand them really well, and you never know while you're solving which particular sorting algorithm will come into picture. So even if, let's say, not the exact sorting algorithm will come in picture, a particular concept of a particular sorting algorithm might help you in solving the problem. Plus, always know that, let's say if someone asks you to implement things from scratch, you should be able to do it. If you understand the concept of a particular algorithm, you should be able to write the code as well. Okay.